Hello. Um, Good evening. Today we are presenting our problem statement, which is machine learning and artificial intelligence for the diagnosis of maize disease. We shall mainly be looking at the maize disease and basically three diseases that we're going to start with, based on the data sets that we are having per time. So there are mainly three authors for this problem statement. There is Bernard Mubarak, which is me, the host. Then there is Ntanda Chimuli, Aloysius, Othieno Benedict Ernest, and Mukisa Samuel Owechtiwa. And okay, yes, a minute. So these are the contents of our presentation. We have the introduction. We shall talk about our introduction, our problem statement, the related works, or any works that have been done in the field of study that we're going to carry out. Then the research questions, the objectives, our methodologies, the experimental and simulation results that we'll be expecting, the conclusions and the future research directions, plus the reference and acknowledgements. So for the introduction, when you look at the perspective of generating money and ensuring food security, maize has been a significant food crop, like almost all houses in Uganda. All of them depend on maize. It's a significant role in both rural and urban cultures. Even at our schools, almost everyone in Uganda has ever eaten maize. And according to a study that was conducted in 2022 by Food Heroes, it was discovered that maize is one of the major staple foods in Uganda and it accounts for more than 40% of persons' daily caloric intake. And over 2 million Ugandans depend on this food as their primary source of income. So thus, the majority of farmers cultivate some maize on their property to meet the nation's demand. So that's why it's crucial to make sure that we maintain this food security. That's actually why we are taking our research in this direction. So our problem statement is that maize disease, when we look at maize, when we look back, we can see that maize has benefited a lot of households in Uganda. So here we are looking at the diseases that actually affect the constant food supplies of these homesteads in Uganda. And maize disease causes farmers, not only the household, but also farmers to lose a lot of money as well as significant increase in the cost of production. And this has occasionally caused some threat of famine because most people depend on this food. It has been cheaper and can be readily available. So that's why this necessitates for the creation of low-cost AI-based systems that can be used to identify the maize illnesses early on, protecting farmers from losses caused by misdiagnosis or delayed discovery of the disease. So if farmers are able to diagnose the correct disease or detect it a bit earlier, they can be able to control it so that they can maintain their food production. That's actually our problem statement. So there have been some work that has been carried out in this area, and the identification of maize disease is a problem that plagues the agricultural community. So several research has already been carried out to precisely identify and categorize maize illnesses. For example, the Cozzolino, Daniel, and Jessica Roberts in 2016 published some document whereby they were talking about a system. It was actually a spectrometry. It uses images and light to detect to actually to detect diseases in maize. But it has been proved that such methods have been quite expensive and they've been impractical to use. You can't take a spectrometry in a farm, and when you look at these farmers, they're actually very poor people. They can't afford spectrometers. So that has proved not to be so practical to our local farmers. So that's why we present efforts. So that's why actually our effort has been to present or to bridge this gap by making these technologies available to farmers at a lower cost through designing models that can actually be accessed by farmers, like for example, through maybe their mobile applications or phones and all that, instead of using the expensive gadgets like the spectrometers. So the objectives of the study is to provide food security and raise the standards of living for farmers via early disease identification, which will increase productivity. Another objective is to increase the competition in agricultural market, because if at all the foods are of high quality, more farmers will start bringing in their crops, and this would actually reduce the prices of food. And also our next objective is to create intelligent system that can boost maize production, thereby modernizing farmers. We want to take our farming to a next level so that we can be like those modern countries. So that's why we want to introduce artificial intelligence in farming. The methodology used is that we're going to design a machine learning model. We shall create a machine learning model which will be trained on some maize photos. We have some maize data sets that we were able to acquire, and this will be divided into 3 training classes as part of the technique. So there is the healthy class, there is the maize streak and the maize leaf blight. The model will next be put to test using a set of maize photographs belonging to the same class, after which it will be made available via a mobile application. The program can then be used to process the images and identify the kind of disease affecting the image. Yeah, so that's how actually our model will work. And this is a representation of how that will work. You can see that this is a leaf image, and this is the process the model takes through to process that image that has taken before giving you the result. Then these are the expected results. So you can see that clearly both farmers and local Ugandans, people gain from this research in a number of ways. They'll benefit in a number of ways. And through the early diagnosis and eradication of maize illnesses, the farmers will be able to increase the yield of maize. And additionally, the research will guarantee Uganda's food security. This we promise you. Here we were able to show you the accuracy of how we were actually showing you how we're going to improve the accuracies of our model. So this is a graphical representation of that. So in conclusion, the study will conclude that by showing that maize illnesses have a detrimental effect on Ugandans. So the claims outline our position on why we should actually use AI-based systems to fight these illnesses. And our future work or the future research will focus on merging the photograph the farmer scanned and the date when those images were scanned, so that we can actually foresee or predict future disease outbreaks. This could assist farmers in making early preparations and attempting to stop the spread of the disease. Actually, there were some people who were able to help us, like Dr. Joyce Navende. She provided us with insight, advice, and helpful recommendations while we were carrying out this research. We also like to express our gratitude to the research lab staff for allowing us to access and use the data sets, because actually the data sets we're using were allowed by the research lab to access the data sets. They were able to come up with the data sets, and these are the data sets we're going to use. Okay, thank you very much. Cool.